So, continuing in section 3.6, this is curve sketching day 2. We're going to take a look at two examples of functions, rational functions, functions with asymptotes, and see how to use all of our derivative tools to be able to sketch them. I'm going to warn you, this is going to get a little messy, but please stick with me on these things. This is certainly as messy as this unit is going to get. I'd like to start by taking a look at the function f of x equals f of x equals x over 4 minus x squared. So I had f of x twice, sorry about that. X over 4 minus x squared. It is a rational function. And my first question for you is, are there any vertical asymptotes? And if so, what are they? Well, vertical asymptotes occur from setting the denominator equal to 0. 4 minus x squared equals 0, x squared equals 4, x equals plus or minus 2, plus or minus square root of 4, plus or minus 2. We have two vertical asymptotes at at 2, and at negative 2. Will this function have a horizontal asymptote, or will it have a slant asymptote? Well, because the degree of the numerator is less than or equal to the degree of the denominator, we just have a horizontal asymptote. Slant asymptotes occur when the degree of the numerator is 1 greater than the denominator, not what I have over here. As for the horizontal asymptote, I'm going to go do the limit as x approaches infinity of x over negative x squared, leading term of the top over the leading term of the bottom. This is the limit as x approaches infinity of negative 1 over x. That's going to give me 0. I would get the same thing if I did the limit as x approaches negative infinity. So I've got a horizontal asymptote at y equals 0. Vertical asymptote, x equals plus or minus 2. Horizontal asymptote, y equals 0. The next thing we need to do is, we're not going to bother with intercepts with these. We're just going to move on to our first derivative and our second derivative. I'd like to see if you can take a moment and calculate your first derivative, simplify it, and then stop. So here's my first derivative work. F prime of x is going to equal, I'm going to use the quotient rule on this. Low, 4 minus x squared, d high is times 1, minus high, x, d low, derivative of the bottom is negative 2x. Draw a line and square below. This is over 4 minus x squared squared. Let's see, I'm going to get 4 minus x squared plus 2x squared over 4 minus x squared squared. This gives me x squared plus 4 over 4 minus x squared squared. And that is my first derivative. Please find the critical values of this. What are the critical values? Well, if you set the numerator equal to 0, x squared plus 4 equals 0, you're not going to get anything. X squared equals negative 4 plus or minus 2i. That's not helpful. From the denominator, well, 4 minus x squared equals 0. You're going to get x squared equals 4, x equals plus or minus root 4 plus or minus 2. Critical values at x equals plus or minus 2. I'm going to go make my number line. Negative 2, positive 2. I'm going to label this f prime. Actually, I think you can handle plugging in. Take a moment, go plug in, get your signs. Okay, plug in 3. You know what? I don't even care about the denominator. That's always positive. Oh, and actually, the numerator is also always positive. X squared is always positive, plus 4 will make it positive. Plug in 3, you're going to get something positive. Plug in 0, 0 plus 4, 4 over 4 minus 0, 4 squared, positive. All the regions are going to be positive. We're going to be increasing everywhere. So no maxes, no mins, none of that stuff. We now need to find the second derivative. And I think we're going to do some of this together, because here's where it gets a little messy. I'm going to leave my first derivative in this form, and I'm going to use the quotient rule, just keeping in mind that there's going to be some chain rule stuff involved when I go to do the derivative at the bottom. F double prime of x is going to equal low 4 minus x squared squared d high times 2x. See if you can go do your high d low. High x squared plus 4, make sure you're being good with parentheses here. D low, okay, so I'm going to take care of that square. By the chain rule, I now need to multiply by negative 2x. Draw the line and square below. 4 minus x squared 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 will give me 4 minus x squared to the 4th on the bottom. This is ugly. I need to do some work with this. F double prime of x is going to equal, okay, I'm just going to clean this up for right now, 2x times 4 minus x squared squared. The double negatives are going to make this a plus, so plus 4x times 4 minus x squared times x squared plus 4 all over 4 minus x squared to the 4th. I want to see if you can take a moment and factor out the GCF of the top. Actually, you know what? Factor out the GCF and see how far you can get with simplifying. If you do it correctly, it'll become nice enough. So I'm going to go and I'm going to take out a 2x and a 4 minus x squared. And I'm left with, okay, the 2x is good. I need a 4 minus x squared to the first. Next part, 2x times what gives me 4x? I need a 2. I'm good with the x. I'm good with the 4 minus x squared, but I need that x squared plus 4 to show up in there. This is still over 4 minus x squared to the 4th. Let's see. I'm going to distribute and combine like terms here. Over here, I might as well deal with my 4 minus x squared over 4 minus x squared to the 4th. I can make one of those cancel, giving me 4 minus x squared to the 3rd on the bottom. If double prime of x equals, okay, let's see, 2x. In the denominator, I've got a 4 minus x squared cubed. Now I've got 4 minus x squared plus 2x squared plus 8, which gives me 2x, times x squared plus 12 over 4 minus x squared cubed. That is my second derivative. These second derivatives in this section are going to be hard. However, they're all going to work in a similar way. We're going to use quotient rule, probably with some chain rule involved, maybe, maybe not. But then to simplify things, we're going to need to do some factoring out with the GCF and canceling and all that. I want to see if you can go find your possible points of inflection. Actually, what are those possible points of inflection? Let's see, possible POIs. From the numerator, I've got x equals 0. From x squared plus 12, I'm not going to get anything. Set x squared plus 12 equal to 0, you're going to get x squared equals negative 12. You're going to get imaginary things there, so that's not useful. From the denominator, same deal as usual. I'm going to get 2 and negative 2, same thing that I got when I tried to get my critical values. Go make your number line and find the points of inflection. Okay, let's see. I've got negative 2. I've got 0. I've got 2. Okay, plug in 3. you know, this part's always going to be positive. Anything squared plus 12 is certainly a positive number, so maybe I can focus on the rest. Plug in 3, I've got a positive. 4 minus 3 squared, that's negative. Cubed is a negative. Positive over negative will give me a negative. Concave down there. I'm going to plug in 1. 2 times 1 is positive. 4 minus 1, positive. Cubed is positive. Positive over positive will give me a positive. Concave up there. Plug in negative 1. 2 times negative 1 is negative 2 over 4 minus negative 1 squared. That's a positive. Cubed is a positive. Negative over positive will give me a negative. Plug in negative 3. Top is negative. Bottom, 4 minus negative 3 in parentheses squared. 4 minus 9, that's a negative. Cubed is a negative. So I've got a negative over a negative. This is a positive. And we've got our signs. Points of inflection. Negative 2 comma. 0 comma. 2 comma. To find the y-coordinates, we plug back into the original. My original function. X over 4 minus x squared. Okay, well, f of negative 2 is going to be negative 2 over 4 minus negative 2 squared. That's 4. Oh, wait a minute. Negative 2 over 0. I don't think so. That's undefined. And, oh, wait a minute. Back in the very beginning, we said there was a vertical asymptote at x equals plus or minus 2. Of course it's going to be undefined. Yes, concavity changes there, but it doesn't count as a point of inflection, so that's out. And for the same reason, 2 comma something's out, because I'm not actually going to have a point there. Next, f of 0, this one we can do. We're going to get 0 over 4 minus 0 squared. 0 over 4, 0. Point of inflection at 0 comma 0. Okay, I think it is time to graph this. I'm going to set up some axes. That was a little longer than I was anticipating. Okay, whatever. Actually, maybe that's good enough. Below here, I'm going to do my 3 number lines. F, F prime, F double prime. How about you take a moment? The video's going to pause, get those number lines in there, get the asymptotes on the graph, then we'll just put all the pieces together. Okay, so f prime, tick mark at negative 2, tick mark at 2, positive, 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 increasing, increasing, increasing. F double prime, negative 2, 0, 2, positive, negative, concave up, concave down, concave up, concave down. You are put everything together F number line. Should look like this. Then one of these. Then one of these. Then one of these. We need the asymptotes. I've got a horizontal asymptote on the x-axis. I've got a vertical asymptote at x equals 2, and another one at x equals negative 2. If you're feeling brave, take a moment, see if you can do the graph. I'm going to start close to my horizontal asymptote, and I'm going to be concave up increasing until I get to my vertical asymptote. Going to look like that. Then I'm going to start down here so I can curve. Oh, hold on. I totally forgot about my point of inflection. Got to get that point of inflection there, 0, 0. I'm going to start down here. I'm going to be concave down increasing, and it's going to look like that. I'm going to curve around and become concave up increasing. Then I'm going to start down here, concave down increasing, and I'm going to flatten when I get to the horizontal asymptote. And there we go. totally okay that I'm crossing the horizontal asymptote in the middle, because the horizontal asymptote is really all about what's going on when you're far to the left or far to the right. Whew. That was a lot of work. We're going to take a look at one more in the next video.